Guys, in this video we will discuss about that how can we find the continuity or a bivariate function is continuous at a given point AB. So by literal definition of a continuity for the bivariate function is of if a function f of xy is said to be continuous at the point AB if corresponding to a pre-assigned positive number epsilon however small, there exists a positive number delta such that mod of f of xy minus f of AB less than epsilon. Whenever 0 less equal to mod of x minus a less equal to delta and 0 less equal to mod of y minus b less equal to delta. So now the question is that how can we check that a given function continuous at a given point AB at a given point. So let us see now. I here consider one problem here that f of xy is equal to x cube minus y cube by x square plus y square where x not equal to 0 and y not equal to 0 and is equal to 0 whenever xy is equal to 0 0. So now we have to check this function is continuous at the origin or not. So how can we check a bivariate function is continuous? That can be that we can show a bivariate function is continuous if that follows these two postulates or these two conditions, that is the function is well defined at the given point and suppose the point is given there AB, then limit x comma y tends to AB is of f of xy is equal to f of AB. That means the limit must be exist at the point AB. So now for this question, for this problem, we will check the continuity, the function is continuous at origin or not. So first of all, see here this function whenever x not equal to 0 and y not equal to 0, this is well defined, because well defined means the function is there is no singular point. Singular point means the function is undefined, because undefined means sometimes the denominator at some point that will be 0, but here there is no such cases, so we can say that the function is well defined. So now here we have to write that the function is well defined by our observation. Now we have to check that the limit exists or not. As in the previous video we discussed about how to check the limit. So here first we have to find that limit x tends to 0, limit y tends to 0, f of xy is equal to limit x tends to 0, limit y tends to 0. The function f of xy is x cube minus y cube by x square plus y square. If we put y tends to 0, so what we get? Limit x tends to 0 into limit x tends to 0 of x cube by x square. And from here, if we calculate, we get f1. This is a very simple calculation. So now we have to find the vice versa. That is limit y tends to 0 and limit x tends to 0, f of xy. So what we get here? Limit y tends to 0, limit x tends to 0, x cube minus y cube by x square plus y square. So here what we get? That limit y tends to 0 minus y cube by y square, and here from here we get 0. So see here both the values are same. That is, here we can say that f1 is equal to f2. So now we can put y is equal to mx. So if we put y is equal to mx, so here we get from this equation, that is limit x tends to 0, x cube minus m cube x cube by x square plus m square x square. And from here we get limit x cube into 1 minus m cube by x square into 1 plus m square, and if we simplify we get 0, and say this is f3. And in the previous video we know that if f1 is equal to f2 is equal to f3, then we have to put y is equal to mx square. So if we put y is equal to mx square, so we get that limit x tends to 0, x cube minus m cube x to the power 6 by x square plus m square x to the power 4, and from here we get limit x tends to 0. If we simplify it, we get x cube into 1 minus m cube x cube by x square into 1 plus m square x square is equal to 0. So here we get the value is 0, and now we can say that f1 is equal to f2 is equal to f3 is equal to f4, and all the values are same, so we can say that the limit exists and the function is continuous at origin. That means the point 0 0. So I hope you understand the topic. So thank you.